you just listened to were two demos of my Guitar Brain version 1 software made in MaxMSP. I am using a test file to highlight the differences in musical effects you can create depending on the material you choose to load into the corpora. This is my submission for my data and machine learning final project. The dependencies for this software include the FluCoMa package that can be downloaded from the Max Package Manager and the NN tilde object that can be downloaded from the Rave GitHub page or the ERCAM forum. I am going to try and make this presentation as concise as it can be, as there are a lot of features I would like to go through. For more information on specifics, you can find these in the written commentary. I will explain the basis of the software, how to use it, and then finally show a live instrument demonstration. Essentially, the software was created as a reactive musical improvisation partner, focusing on a particular type of technique-specific guitar improvisation. Improvisation that focuses around using extra guitar gadgets, the EBow and guitar slide, and features the use of chords and natural harmonics. It features 3 core areas of exploration related to data and machine learning. Firstly, input classification using an MLP classifier. Secondly, corpus exploration with a 2D plotter, the high dimensions of loaded audio file data reduced with the UMAP algorithm. And lastly, a neural audio synthesis model implemented through the NN tilde external object and trained in Google Colab with the Rave algorithm. I will now demonstrate how to set up the software using the steps laid out in the README subpatch. Number 1. Set input. In the top left corner, either set up your live input or load an audio file to test the system. I have also included MIDI input, as there is some MIDI pedal functionality, but this will be a feature I'll improve on within a future iteration of the software. Number 2. Load corpora material. You can load a single file, folder, or record into the corpora. The larger the amount of files, or the longer the recording, the longer it will take to perform the analysis. Changing the grain size to the left will affect the traversal speed and the resultant sound. There are 5 different corpora, based on different forms of analyses. These include mel frequency coefficients, pitch, mel bands, chroma, and spectral. Each have different musical effects, some of which are explored in depth within the behaviors subpatch. The brain of the system is the MLP classifier output. Once the guitar technique is recognized, it will send out an impulse to a random selection process that chooses between 6 different outcomes, 6 for each technique. These outcomes turn on the corpora behaviors and bypass the technique-specific audio effect. The user can set the sensitivity. This is how quickly the system will react after recognizing the technique, setting an interval before the next change. Only one behavior is allowed to be in effect at once. This doesn't account for the audio effects though. Each behavior and audio effect has a monitor flag to show when they are active. There are corpora-specific behaviors, an example being the chroma harmony behaviors, or the more general behaviors, such as the envelope following, which can be applied to all 5 of the corpora. I would implore you to have a test run and try and discover which effects and behaviors you want to include within a performance. You can test out the audio effects on the main patch page using the label toggles and using the T1 bang in the behavior subpatch to test out a behavior. You can remove a behavior from the possible decisions made by the classifier by turning on the remove toggle, the processing page. The 4 main audio effects are reverse delay for the guitar chords, lossy and an effect that simulates lossy digital audio for the guitar harmonics, a harmonizer for the EBow, and the texturizer for the guitar slide. I have also included 2 versions of the terminus reverb. Change the settings at will. They relate to both the input signal and the corpus output. The user has preset control over the harmonizer, reverse delay, and reverb. This can also be controlled by the pedal control, or they automatically change after a period of time, which the user can set from the main page. I would recommend for you to set the effects to your liking before use, even create your own presets for the system to cycle through. This will personalize your performance. Now onto the Rave implementation. I included this as an additional feature as it is something I had been working on as a side project. It is a model trained from a large dataset of acoustic drum breakbeats. I recommend for the best result, use these features standalone. I have included 2 modes, Rave 1 and Rave 2. Rave 1 is the standard forward encode and decode for the latent space, and Rave 2 uses an XY grid to manipulate in real time 2 dimensions of the latent space. Now I am going to present the software with the use of live guitar input, showcasing firstly the Rave functionality, and following that, improvisations focus on each of the 4 trained techniques.